we've been here, right? This slide. And we were talking about tastes or preferences. All right, so for goods, like A and B are two different goods or two bundles of goods. And we may compare how much we like them, okay? Hence the pleasure we may derive from consuming A or consuming B. So if A may bring us a higher pleasure, a higher level of pleasure, then we will say A is strictly preferred to B. We prefer A strictly to B, okay? And this kind of relation, we call it A is weakly prefer to B, or we prefer A weakly to B, which means we like A, we enjoy A, consuming A, at least as good as consuming B, at least as good as, okay? So at least the same, no worse than B, okay? And we call this is consuming A is indifferent to consuming B. It's indifference, okay? But if we are talking about real values, real numbers, for example, X and Y are two real numbers, like it's a 5 or it's a 3, then we call X is greater than Y, or X is greater than or equal to Y, which means X is no less than Y, and X equals Y. So if X and Y are two numbers, we may compare using the relation symbol we are quite familiar with, right? And you'll see the symbol here to denote the relation. It's a little bit different. There is a curve here. It's a straight line. And it's something with some curve, okay? So notice this. There's some. So we are talking the relation, these three types of relations over good. So A, B are goods. We are consuming them. And X, Y are real values, okay? And this week, at first I'd like to introduce some properties of preferences. The first one is completeness. 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 What does completeness mean? When there are two goods or two bundles of goods in front of you, okay? So you may decide which one is better, and which means you may instantly decide whether A is preferred to B. You like A more than B. So you prefer A to B, or you prefer B, or they are indifferent to you, right? So totally there are three. You may decide which kind of relation, of preference relation is. Once again, whenever two bundles of goods or two goods in front of you, they are brought in front of you. So you may decide instantly which one you prefer, okay? So you may prefer A, or you may prefer B, or you may think they are indifferent. Is that clear? So when whichever two bundles of goods brought in front of you, you may do that. We call this completeness. Completeness. So something, when facing a choice between two bundles of goods, like A and B. So you may rank, you may have an answer which one it is. It won't be something like, oh, well, I don't know, I can tell you which one it is. You must be able to answer this, which we call it completeness. Okay? Either A is preferred, or B is preferred, or A and B are indifferent. You must be able to tell the answer. And the second property, we call it transitivity. Transitivity is something like this. If you prefer A to B and you prefer B to C, then you must prefer A to C. So we call this transitivity. So your rankings are logically consistent. It wouldn't be something like a circle. You prefer A to B, you prefer B to C, and then you prefer C to A. There won't be this kind of cycle, okay? So if you prefer A to B, you prefer B to C, then you prefer A to C. There must be something like a ranking, okay? So we call this transitivity. And the last one, the third, is more is better. More is better. So something you like, for example, Haagen-Dazs ice cream. You like Haagen-Dazs ice cream, so for a cup of the ice cream, and how about 2 cups of the ice cream? You must prefer 2 to 1, right? So something you like, and the more, the better. So all else the same. Other things being equal, more of a commodity is better than less. More is good. And actually we use this property to define something, we call it a good. A good is something we like it, something we like. But there must be something we hate or something we dislike, right? And we call that kind of things, like a bad, like pollution. We don't like pollution, okay? So maybe someone just doesn't like, for example, mushroom. I don't like mushroom. So mushroom is something bad to me. And what about more is better? So my preference violates this property, right? So if you may get rid of mushroom, so getting rid of mushroom, I had mushroom, right? But getting rid of mushroom, you take it away, I would say thank you, right? I would like it. And if there is a plate of mushroom, say there's 1, 2, 3, 4, 5, 6 in front of me, and I was enforced to eat these mushrooms. But if you may take something away, take 1 away, then I would say, oh, better, thank you, right? And you take 2, I would say, thank you very much. I would say, thank you, really, really. I'm really happy, right? Appreciate. So you get rid of something I hate. I would denote, or I will regard this kind of thing like a good. So take off garbage or take off pollution. You just take it away. Get rid of these bad things is a good thing. Is that clear? So more pollution makes us worse, but less pollution, which means we get rid of pollution. Okay? And the last one, something like actually we don't need the translation. It's quite clear here, right? Okay, so we just introduced to you 3 types of properties of preference. One is completeness, the second is transitivity, and more is better. Of course, there are some more properties about preferences, but we do not introduce here. Maybe some advanced microeconomics, like when you go to the master degree, and you will learn something more, okay? So, is everyone happy with these 3 properties? So I assume all of you understand what we are talking about, right? Think. Completeness. What is completeness? Just go through your brain. And transitivity. What does transitivity mean? More is better. Okay? And the set of all bundles of goods that a consumer. The first thing I need to tell you why we use a bundle of goods. In this class, it is a medium class, medium level of the microeconomics, and we may have diagrams like this, 2-dimensional diagrams. But in advanced level of microeconomics, like when you go to the graduate school, and we will have like n-dimensional analysis. But here we just analyze 2-dimensional analysis. So, I forgot. So if we have 2 types of goods, like hamburger, like Coke, so we may have 2 types of goods. And for each point on the diagram is a R² diagram. Dimensional 2, right? 2-dimensional diagram. So this is a 2-dimensional diagram, and each point on the plan, may denote, say, 2, 5, which means 2 hamburgers, 5 cups of Coke, okay? 5 cups of Cokes, not Cokes, Coke, okay? And like, okay, 5, 2. It's another bundle. It's the bundle of this point, representing 5 hamburgers and 2 cups of Coke. Okay? So for any point on the plan, on the 2-dimensional plan, it is a bundle of goods. Get it? So you understand what the bundles mean? What does bundle mean? It's a combination is a combo, okay? All right, so the set of all bundles of goods that a consumer views as being equally desirable can be traced out as an indifference curve. So the first thing here, I'd like to introduce to you something, a noun, a professional noun in microeconomics, something new to you. Indifference curve. This may be the first time you just see the term indifference curve, but something I believe you must already know it. We call it iso-height curve. height. What does height mean? It's height, right? Iso means equal height. So if I just draw something like this, and I denote like 100, 200, 300 meter. So what do you think these circles represent? What do you think these circles represent? Is a hill, a mountain, or a pit, or a valley? It's a hill, right? Something you will see is something like a mountain or a hill. Mountain or hill, okay? But if I give you something like this, it's like 100, 200, and 300. So it's something inside, right? Something concave, or pit is a pit, or a valley. Get it? So it's a valley, it's a mountain or a hill. And what do you think this circle means? Which means the point here on the map, or the point here, their heights are equally the same, 100 meters, right? And the heights of these points are 200 meters. Okay? We call this kind of curves like iso height because the height they present are the same. They just present us the same height. Okay? So, in this classroom, I may also use something like a same age curve. So I may ask you, how many of you are aged like 19? Anyone? Your age is 19? 19. Raise your hand. Alright, so I may just plot these seats. It's a 19 zone, okay? And how about 20? Your age is 20. So there is a 20 zone or 20 curve, okay? So it's a iso age or iso height. Iso something that means something equal. And we put them together, we chase them together using a curve, okay? So it's an iso height curve. And you will compare the numbers here, you just understand, oh, there is a mountain here, or there is a hill here. And you just compare another iso height curves, and you, oh, see, there is a valley, or there is a pit over there. Okay? So we want to know what does indifference curve mean. Indifference curve means all points on the curve just bring us the same level of happiness or same level of pleasure. So we may regard these points on the same indifference curve as indifferent. Remember, we just say A is indifferent to B, right? If A and B are indifferent to us, which means A and B will locate on the same indifference curve. Is that clear to you? Is everyone happy with this definition? Okay, so now let's try very hard. Now, you don't have to do something very hard. It's actually quite simple here. So we have good X and good Y, just like hamburger and Coke. Okay? And for a specific point here, we want to find out which points on the plan are indifferent from this one. So we may divide the plan into 4 regions, 4 areas. Okay? What do you think area A? Do you think points in this region can be indifferent from this one? Can they be? Can they be or not? The answer is no. And the reason is I just gave you 3 properties of preferences. Completeness, transitivity, more is better. Which one you may apply to inference the result? More is better, good. Because any point in this region, we got more x than this point, right? And we got more y than this bundle. So the bundle, this bundle must be strictly preferred to this bundle. Okay? Because more is better. Alright? So more is better, so that's the reason why we do not have any point in this region giving us the same pleasure, the same level of pleasure, the same level of happiness than this one. Okay? And so the same reason, or the just opposite reason, opposite inference, is that there cannot be in this area, this region. Because the more is better, the property more is better, so any point here, like a star here, this point must be preferred to this one, right? Strictly preferred to this one. They just cannot be indifferent. So you know, only points in this region and point in this region can be indifferent to this point. They are candidates. They are candidates to be on the same indifference curve with this one. Is that clear? You see, for this point, although this point has more x than this one, but it has less y than this one. Okay? And this is the opposite example. So let's have a look. We have a lot of points on the plan, 2-dimensional plan, and for point E, if we divide the whole plan into 4 regions, and this one cannot, and this one cannot either. So if we want to chase out an indifference curve, which means point C and point E and point A, these 3 points brings us the same level of pleasure. Okay? So we regard point C indifferent to point E, indifferent to point A. Because they are indifferent, so we put them on the same indifference curve. Is that clear? And now we have the very good result or conclusion that the indifference must be negatively sloping. Indifference curve must be negatively sloping. Negatively sloping. Due to the property that more is better. If more is better holds, then the points indifferent to this one cannot be here, cannot be in here, cannot be in here. It must be in these 2 regions. So the indifference curve must be a negative sloping curve. Get it? negative sloping. So we have some important properties of indifference curves. Bundles on indifference curves farther from the origin is preferred to those on indifference curve closer to the origin. What does it mean? Okay, one by one here. So now indifference curve are negative sloping. We have one indifference curve, another indifference curve, and the third indifference curve, fourth, fifth, something. So 100, which means these points on this indifference curve bring us, or bring me, the level of happiness is 100 points. Okay? And 200, 400, 700, something like this. And these numbers represent the level of happiness, my level of happiness. So you will see, the more is better, the more the better. So points on this indifference curve must be preferred to points on this indifference curve, right? And prefer to this. So if there is A, B, C, and D, without any constraint, without any limit, I can choose whichever I like. Which one do you think I will choose? Which one do you think I will choose? Of course D, right? Because D gives me the highest satisfaction. Okay? I'm satisfied most with this point, because this point is located on the indifference curve denoted by 700, the highest number. Okay? And the reason why the farther, not farther, okay? The farther from the origin, are preferred to those closer to the origin. And this property comes from more is better. Okay? And every bundle lies on an indifference curve. On an indifference curve. Why I just use red and bold to remark this term.
Seems that difference curve will cross each other.
Yes. So something like a bundle A, it just gives us a specific level of satisfaction or happiness, and it just cannot give me two levels of happiness. Okay? So I wouldn't say, oh, A brings me 100 happiness, and it gives me 700 happiness. Just one number. Okay, so the satisfaction level must be something. And the something, like 100. So the indifference curve, which means every point, whichever gives us 100 level of happiness, will locate on this indifference curve. So it must be one indifference curve, cannot be two indifference curves at the same time. Okay? So indifference curve cannot cross. It cannot cross, which means we cannot have something like this, and we call it like 500. We cannot have this kind of things because this point gives us 5 degrees of satisfaction, and this point gives us 100 degrees of satisfaction. And the intersection of these two curves